All right, joining me now is Dr. Dan Lindsey from NOAA, talking about NOAA's newest satellite launch. Dr. Lindsey, thanks for joining us, and tell us about this exciting new satellite that you guys are working on and launching.
Thank you so much for having me. Yeah, so GOES-U is going to launch this afternoon, 5:16 p.m. Eastern Time, and it will join 3 other GOES satellites that are already in orbit, GOES 16, 17, and 18. After GOES-U reaches geostationary orbit, it will be renamed to GOES 19 and be the 4th and final in the GOES-R series. Following checkout, they're going to move GOES 19 over to the GOES East location at 75 degrees west longitude. That's roughly over the eastern part of the U.S., and where it will serve as GOES East for many years into the future.
So for us up here in Buffalo, what are the benefits of some of these new satellites? They have better sounders, the imagery is better, more detailed. What can we expect with this great new product?
Sure. So for this new series, newish series that we'll call it, of satellites, the GOES-R series, compared to the old, there were a lot of improvements. One of them is sort of better resolution. And what that means is you can think of it as if you take a camera and you upgrade your camera to a better camera with better resolution. That means when you zoom in, it's less blurry. You can sort of zoom in further and see things that are smaller. It's the same idea with a satellite. You can zoom in and see, for you guys, for example, if there's any ice on the lake, you can actually zoom in and track the ice as it sort of sloshes around during the springtime. And its main application is really tracking weather systems. So this could be anything from thunderstorms in the summertime to winter storms to lake effect snow bands that affect Buffalo almost every year.
No doubt. And obviously when we're tracking some of those big thunderstorms with 30, 40, 50 foot 30, 40, 50,000 foot cloud tops. Obviously, especially on the visible spectrum side of that, it's an unbelievable product.
Absolutely, yeah. We can scan these storms as frequently as every 30 seconds. And when you do that, it's sort of like time lapse from space. You can see the bubbling nature on the tops of the storms, and that gives you an indication of how strong they are.
For sure. And I would imagine for our friends closer to the coast, for tropical meteorology, I mean, picking up those eye walls and eyes in a hurricane, it's just so much more detailed and so much more specific.
GOES East is absolutely critical for tracking hurricanes. We zoom in at, like you say, to the eye, pinpoint the latitude, longitude, and the direction and speed that the storm is moving. And that information is then fed into the numerical models that tell us where are the storms headed. Are they going to hit Florida? Are they going to hit North Carolina? Are they going to recurve? Really important information for those residents.
Yeah, and satellite and radar meteorology, critical in tropical system forecasting here, trying to see, obviously if that storm is weakening, if it's getting hit by wind shear, upper level winds. What other components might be on that satellite aside from, let's say, a visible and an infrared satellite channel, other channels that we might be able to find on there too?
Well, there's a second Earth pointing instrument in addition to the imager, which we've been talking about. It's known as the Geostationary Lightning Mapper, or GLM. And for the first time with the GLM, we were able to continuously watch lightning throughout almost the entire hemisphere. Lightning, as you know, can occur both with tropical systems like we were talking about, or, most every thunderstorm, almost by definition, has some lightning associated with it. And so being able to trend the lightning activity can tell us, is the storm weakening, is it strengthening, or, what is it going to do here in the next few minutes?
I mean, will it be sensitive enough to delineate between cloud to cloud lightning and cloud to ground?
So generally the answer to that is no, but there is some research going on where, we can, certain characteristics we'll say of the lightning as observed from the satellite instrument may be able to tell the difference between cloud to cloud and cloud to ground.
That's unbelievable. It's a really hard thing to pick out and to differentiate. And obviously with any lightning, you want to take precaution and move the festivities indoors. Certainly don't want to be at a golf course or things like that. So launching today, and yes, likely lifespan, how long this thing's going to be in space for?
So the GOES satellites are planned, they're designed, I should say, for 10 years of operational lifetime. Sometimes they last even longer. We've had these things going, some of them for 15 or even 20 years. So, we'll use them as long as they're useful. But in terms of the design, we expect at least 10 years of lifetime from GOES-U.
So is GOES 20 in the works already? Thinking about the improvements for the next one?
Yeah, great question. So since this is the 4th and final launch in the GOES-R series, we're already planning for the future series where there's going to be significant improvements in the technology. And we call that Geostationary Extended Observations, or GeoXO. GeoXO is planned for its first launch in 2032. And there will be three new additional Earth pointing instruments that we don't have now, as well as a new central satellite that will complement Goes East and Goes West. So we're really super excited about that GeoXO program.
Wow. At this point, I know it's early and preliminary, GeoXO will be able to do what that current satellites can't do?
So there's several things. We are going to be improving that imager. It's the instrument we've been talking about that zooms in on the clouds or the hurricanes. So you get about 4 times better resolution in the visible and 4 times better resolution in the infrared as well. In addition to that, we're going to be adding a new instrument called a hyperspectral infrared sounder. A lot of words. What that really means is it gives you a better indication of the temperature and water vapor distribution throughout the troposphere, sort of the vertical distribution. And that information is critical to feeding into the models and letting the models do a better forecast. The last 2 instruments that are going to be new are an ocean color instrument for looking at things like harmful algal blooms, which can certainly occur in the Great Lakes as well as an atmospheric composition instrument for looking at air quality and pollution.
Right, so 2 things that, and all of this more important in this age, an era of climate change, of a warming planet, water temperatures. Of course, we've seen the wildfires, so things of that nature, all critical elements to forecasting and to our environment as well. So Dr. Dan Lindsey from NOAA, the satellite division there, thanks so much for joining us, and I appreciate the conversation. Really amazing stuff you guys are doing.
Thank you so much for having me.
Sure.